As you watch this segment, think about how Earth's magnetic field is formed, how it changes over time, and how it protects Earth. Earth is a gigantic magnet with a magnetic field that stretches into space. Though scientists have known about Earth's magnetic field for some time, it is only recently that researchers like Gary Glatzmeyer have been able to create a model of what the magnetic field looks like and why it changes. Here at the Los Alamos National Laboratory in New Mexico, Glatzmeyer has developed a mathematical model that literally paints a picture of our planet's changing magnetic field.
The model predicted or told us that the inner core, the solid inner core, below the fluid, is actually rotating slightly faster than the surface of the Earth.
And this slightly faster rotation sets up a magnetic field. This field emerges from Earth at one pole and returns at the opposite pole. The poles are where the strongest magnetic forces are located. Earth's magnetic poles are some distance away from the actual geographic North and South poles, and their positions are slowly shifting. Earth's magnetic field is similar to the magnetic field that surrounds a bar magnet. A magnetic field is created by the movement of electrons spinning around the nucleus of an atom. A single atom by itself won't have a very strong magnetic field. However, the magnetic fields of billions of atoms can combine to form more powerful magnetic forces. This animation shows a ball that represents an atom. The red half of the ball represents one magnetic pole, and the white half represents the opposite pole. This cluster of balls represents what happens when billions of atoms line up and form a strong magnetic field. When all the magnetic fields are lined up in the same direction, just like the magnetic fields of these balls, they create a magnetic domain. If all or most of the magnetic domains in a material are lined up in the same direction, then the material will have a very strong magnetic field. Not all materials can easily form magnetic domains. Iron, nickel, and cobalt are examples of materials that can. Such substances are called ferromagnetic materials. Now think back to Earth. Its liquid outer core and solid inner core are made mostly of the ferromagnetic materials iron and nickel. Earth, too, can form magnetic domains. How does this happen? One possible explanation is that magnetic fields form as a result of movements of Earth's liquid outer core. The fields extend through Earth's mantle and crust and thousands of kilometers into space. Scientists also know that Earth's magnetic poles shift from time to time. The town of Estelmuir in Scotland seems like a quiet countryside, but here one of nearly 200 observatories around the world work around the clock monitoring the state of Earth's magnetic field.
The instruments in the observatory are isolated, and the observatory itself is isolated because we want to measure the natural field of the Earth rather than artificial fields from man-made sources.
Keys and locks are made of non-magnetic brass. Some watches and belt buckles aren't welcome here. Magnetic materials like iron and steel are banned from certain buildings so they won't interfere with the sensitive magnetometers. Magnetometers detect the tiny currents that move through loops of wire when the magnetic field around them changes. Measurements of Earth's magnetic field have shown its magnetic poles are not stable. Instead of staying completely still, the poles can, and do, shift. Some scientists think that the shifting of magnetic poles may have had a slight effect on our planet's climate.